Hi guys, welcome to Chem or Chem. In this video, we are going to see phenacol-pinacolone rearrangement and their basics and mechanism. If you are new to this channel, please subscribe. So now we move on the video. So in phenacol-pinacolone rearrangement reaction, vicinal diols can be converted into the corresponding ketones or aldehyde in the presence of acid. So next question is, what are the acids? Acids can be useful in order to conduct these reactions. In most of the times, cold aqueous solution of sulfuric acid can be useful. Apart from the cold aqueous sulfuric acid, other acids such as perchloric acid and phosphoric acid also useful. And also Lewis acid such as PF3, etherate as well as TMS O-triplet also suitable for conduct this type of phenacol-phenacol rearrangement reaction. So next we move on the mechanism. In this reaction undergoes by 4-step reaction. We'll see one by one. So now you take these vicinal diols. Here you see these vicinal diols has 2 hydroxy groups, as well as this carbon has 2 methyl, as well as this carbon has 2 methyl groups. So when you subject under the acidic condition, one of the hydroxy group has the lone pair of electrons. Here you see this lone pair of electrons takes the proton from the acid, which leads to generate corresponding protonated alcohol intermediate, which readily lost the water molecule that generate corresponding the carbocation intermediate. So once you get the carbocation intermediate, here you see one of the methyl groups migrate to this carbocation center. This shift usually called 1,2 shift, which leads to generate one more carbocation intermediate. Here you look, this one tertiary carbocation, as well as again this one also tertiary carbocation. So now your mind most possibly will get some questions. This one also tertiary carbocation, again this one also tertiary carbocation. What's the need of migrating this methyl group here to here in order to generate one more tertiary carbocation intermediate? So this is the answer. So whenever you see the carbocation near to the hydroxy group, that hydroxy group always stabilize that carbocation through resonance. Here you see this lone pair of electron stabilize this carbocation intermediate by resonance in order to generate one more resonance structure. Once if you get this resonance structure, quickly fall off the H plus ions, which leads to generates the corresponding ketone product. Now you take this example. Here you see this one is completely unsymmetrical vicinal diols. This carbon has 2 phenyl group, and at the same time this carbon has 2 methyl group. This one is completely unsymmetrical vicinal diols. In this situation, definitely in your mind you will get this type of question: which hydroxyl group is lost as water, or which intermediate carbocation is more stable? So we will see one by one. Here we choose one of the hydroxy group as green circled. When you subject under the acidic condition, you will get this type of protonated alcohol, then followed by elimination of water, you will get this type of carbocation. And similarly, now you choose this circled hydroxy group, you will get corresponding protonated alcohol intermediate, then followed by elimination as water molecule, you will get this type of carbocation intermediate. Now you see which carbocation is more stable one. So this carbocation is stabilized by resonance, while this carbocation is stabilized by hyperconjugation as well as plus I effect. When you get this type of situation, you always remember this rule: resonance always will get more priority than hyperconjugation as well as plus I effect. According to this, this corresponding carbocation is more stable one, then followed by 1,2 migration will take place. That means that methyl group migrated towards this carbocation center, then followed by generate this new carbocation center. And so this carbocation we already seen this carbocation is stabilized by resonance and followed by elimination of H plus ions that generates corresponding ketone product. Okay, now you see this symmetrical onto diol when you subject under the acidic condition. So here no matter which hydroxy group will get to eliminate as water molecule, because this one is a symmetrical molecule. So one of the hydroxy group readily react with H plus, which leads to generate protonated alcohol, then followed by elimination as a water molecule, you will get this type of carbocation intermediate. So now there will be a question: So what is the inherent migratory aptitude of the different substituent group? Since here you see phenyl as well as methyl, here there are two groups. Which group will migrate to the near carbocation center? So you always remember this rule. More nucleophilic groups tend to be easily migrated. That is, electron-rich group always easily migrate to the near carbocation center. So based on this, we will form the series of the migrating ability. In this series, hydrogen, aryl, vinyl approximately equally tendency to move the near carbocation center. And when you see the alkyl groups, tertiary alkyl always get more priority than secondary as well as primary. And finally, methyl has least tendency to migrate to the near carbocation center. Based on this, phenyl group easily migrate towards to the near carbocation center, which leads to generate this carbocation by 1,2 shift. This carbocation we already seen that more stable by resonance, and followed by you will get this type of resonance structure, and followed by elimination of H plus ions, which leads to generate this ketone product. So next we are going to see the influence of sterics and other strain factors on this rearrangement. For example, when you take the cis diol, here you see cis diol. In order to visualize this the mechanistic details, we need to convert into the corresponding chair form, and similarly trans diol also we need to convert into the chair form. So now you see cis diol chair form. So here two hydroxy group, one of the hydroxy group present in the axial position and another hydroxy group present in the equatorial position. This particular axial hydroxy group encounter the steric class between the 1,3 diaxial interaction. Due to that steric reason, when we subject under the acidic condition, this axial hydroxy group selectively protonate, and followed by the kick of the water molecule, you will get this type of carbocation intermediate. So once if you get the carbocation intermediate, next step will be a 1,2 shift. So here methyl group shifted towards to the carbocation center. So here I would like to remind you that one important rule, whenever you see that rigid ring system, you always apply this rule. So here you see this, according to this rule, anti-periplanar or trans group always will migrate. So according to this rule, here you see that methyl group present in the exactly anti-periplanar position. For that reason, methyl group selectively migrate towards to this carbocation center. So further, if you want to visualize this concept, so you just convert this chair form into the corresponding Newman projection. So first you take this carbon present at the back side, this carbon present at the front side. So first we will fill the back side of the carbon. So this back side of the carbon attached with one of the methyl and the top protonated alcohol. So put the protonated alcohol and methyl group in the right side, as well as this CH2 present in the left side. So now you go for front side carbon, this front side carbon here, front side carbon. So in the bottom methyl group, so in this carbon, left side on CH2 group and right side on hydroxy group. So now you see this methyl and this protonated alcohol present in the anti-periplanar or trans position. So similarly, this methyl and this CH2 present in the anti-periplanar, and similarly this CH2, this hydroxy group in the present in the anti-periplanar position. So here in this structure, methyl group present in the exactly anti-periplanar position. So this methyl group migrated towards to the carbocation center, leads to generate this corresponding ketone product. Now you imagine when you protonate this hydroxy group, that means that equatorial hydroxy group. So you will get again protonated alcohol, then followed by kick of the water molecule, you will get this carbocation intermediate. So in this particular intermediate, so anti-periplanar position, that CH2 group present in the anti-periplanar position. So this second carbon migrated towards to this carbocation center, leads to ring contraction takes place, which provides corresponding 5-membered ketone product. So now we come to the trans diol. So here you see trans diol. So here the both hydroxy group present at the equatorial position. So that means that no problem at all which hydroxy group will get more priority on the protonation step. So both hydroxy group will get equal opportunity to get protonation and followed by kick off the water molecule in order to generate the carbocation center. So first you will choose this hydroxy group, you will get this carbocation intermediate and followed by that 1,2 shift takes place. Here you see the fifth carbon exactly present in the antiperiplanar position. So which leads to ring contraction takes place that generate corresponding ketone. So now you see this hydroxy group. So similar sequence of steps takes place which generate this carbocation center. So now this second carbon exactly present at the periplanar position that leads to generate this ring contracted product. So based on many textbooks, you will see the cis diol ended with the 6-membered ring compound, and similarly trans diol ended with this 5-membered ketone compound. But in this reaction, when you subject under the acidic condition, both cis diol and trans diol present at the equilibrium. So here I already pointed out that axial hydroxy group selectively protonated when we subject under the acidic condition. So once if you subject under the acidic condition, you will get this type of carbocation intermediate. Once if you get the carbocation intermediate readily, water attacks from the equatorial position, you will end up with the trans diol. So now you see the product distribution. So I already pointed out this reaction present at the equilibrium. So here there are only one possible route to get this 6-membered cyclic ketone. But at the same time, this 5-membered ring contracted product, there are 3 possible routes in order to generate this cyclic 5-membered ring system. So based on this, when you take either cis diol or trans diol, doesn't matter. When you subject under the acidic condition, you will end up with 5-membered ring contracted product as a major one and 6-membered ketone as a minor product. So these textbook mistakes already pointed out in the Journal of Chemical Education in 1971. However, in most of the textbooks not yet included these corrections. However, some of the new textbooks have already included these corrections. So I would like to suggest you just consult with your professor which one you should follow, either old textbook mechanism or new textbook mechanism. So in our channel, we discussed a series of esterification, macrolactonization, as well as rearrangement reactions. If you miss this reaction, you just log on our channel, you can find these videos. So in next videos, we will see the problems based on pinacol-pinacolone rearrangement reactions. So until bye-bye.